Okay, let us start this with this question. This is a toroid having n number of turns around it. Okay, there are n number of turns around it in this way, around this, and there's a wire passing through the axis of it, which is carrying current I. Due to that wire, you have to find out what will be the flux passing through this. You can find it out easily by taking inner radius A and outer radius maybe B, and we have a standard formula for finding the flux through. You can find flux through this cross section. Height of this I have to give maybe h. If we have a formula, we can find out the flux, right? And then total flux will be, because it has n number of turns, total flux will be n times the flux through one turn. Once we get the total flux, we can ask the question that if there's a rate of change of current here, what will be the EMF produced here, or what is the mutual inductance between these two? Can we find mutual inductance? Can we find the mutual inductance between these two or not?
Yes,
We can find out because once we know what is the flux passing through this entire, through all the turn, is n times that flux through one turn, then we can find out the that is flux due to in the second thing due to the first thing, flux in the second thing due to the first thing upon current in the first thing. That will be mutual inductance. Okay,
sir,
so we can get, yes.
can we write flux as mu naught IH by 2 pi ln B by A?
That only. What was that? Mu naught. I don't remember the formula. Mu naught IH
By
log
2
of
pi B by S.
by 2 pi that only.
Yes, sir.
That is the flux, but it is through one turn. We have to multiply by
N.
and to get that flux is the
flux
total
by
torque. Then after getting that, then flux divided by current will be mutual inductance, which will be n into mu naught into h by 2 pi into ln b by a. But I don't remember this formula. Is it right? Formula. Are you sure it is right? Because I don't remember this. I have to.
Sir, as it is rectangular question is the correct only.
No, same way I have derived it before that only, but it will be like this. It is x, it is dx, it is h, then mu naught into I divided by 2 pi x, that is the magnetic field, into h into dx integral, limits from a to b. That only, I think that only we are getting. That only or not?
Yes, sir.
It's the same, sir.
Same only. Same only we are getting. So let me write it here. How much time it will take? Mu naught into I divided by 2 pi r into h into dr. Limits a to b, and total flux will be n times that. Okay. Right. What is mutual inductance? Have I taken the question of mutual inductance before or not?
No, sir.
Yes.
Huh?
Mutual induction due to a wire and the loop we have taken.
And then I have taken this kind of question only. That also same only. Okay. But I may have to take, I can take some other questions of mutual inductance. Let me start here. Mutual inductance. One more question which we can take is this one and this one. Take the radius of the bigger loop to be B and the smaller to be A. A is very small as compared to B. And the smaller loop is inclined at an angle theta with the first loop. This is area vector. It is a way of telling that what is the angle of inclination of the loop. If I know the angle of inclination of area vector, then I can tell the angle of inclination of the loop also, because they are mutually perpendicular to each other. I can say loop makes what angle? Loop will be making 90 minus theta angle with the axis. If the plane of the loop is making 90 minus theta, then automatically area vector will be making theta. Okay. Is it right?
Yes, sir.
Yes, sir.
So let me mention here 90 minus theta as well. 90 minus theta. This is, I think it is the plane of loop. Angle between axis and plane of loop, that is this angle 90 minus theta. They say sometimes like this. This is a typical question that is asked. The current in the smaller loop is I. Find the flux to the bigger loop. What is the question?
Current in smaller loop is a flux to bigger loop.
Flux we have to find in bigger loop. Exactly. Now you do it. Let me write it slowly because I have already stated the problem. By the time I will finish writing, you can start attempting. Or you may write the question by that time. It is your choice. How to do? What we will do? We will do opposite. We will not see what they have given to us.
Sir,
Yes.
is there any current flowing through B, sir?
No. It is flowing through A. We have to find flux through B. Due to A, also magnetic field lines will be there, so magnetic field lines will be passing through B or not.
Yes.
Questions about that?
We'll use mutual inductance.
And also don't forget this condition. A is very, very small as compared to B. What we are going to do?
Sir,
Mutual induction, sir.
Yes.
sir, distance between the
We will do opposite. We will find the. We will take the current in the bigger one as I. And yes, he's right. Distance is needed. Distance between them is given. Assume that to be given to be equal to x. Distance between these is given as x. Okay. Distance between the centers of is x. Distance between the centers of the loops is x.
mu naught a square I cos theta by 2 pi x cube I'm getting, sir.
I think, but it is better right in terms of A1 and A2. We can write as a dot product. Right or not? Area vectors. So what is the magnetic field due to the bigger one in the near the smaller one? That we know the formula for it, right?
2kp by r cube.
2k m by
R cube. I mean,
r.
x cube.
R means oblique
X-
distance. Oblique distance.
X
We take
square
as a
plus b square.
X square plus b square all.
this is r here, and this is here. We take will be here. So 2k m by r cube. 2k m by r cube is the magnetic field, and formula is b dot a2, right? Flux will be b dot a2. This is magnetic field. Flux Phi 21 is equal to phi 12. Phi 21 is equal to phi 12. Okay. There is a theorem of reciprocity we call. Theorem of, you don't have to remember the word, but you don't have to remember this, that is theorem of reciprocity. But I think this fact is important for you to remember, that phi 12 is equal to phi 21 is equal to phi 12. What is phi 21 meaning? Phi 21 is equal to flux
into due to 1.
through
Due to 1.
due to current in 1. Similarly, you know what is phi 12. Okay, those will be equal. Because they are equal, therefore we can shift the current from here to the bigger one. Why? Because we really don't know how to find due to this, right? But we know how to find due to that. Actually, let me tell you the fact. I can find due to this also in that. How? By taking it as a dipole, small dipole, and due to dipole we know the field here. Then, but we have to integrate. On the other hand, if I take due to bigger one on the smaller one, then I don't have to integrate. I can directly multiply by its area and we can get the answer nearly. You can try the opposite. You can try this. Take it as a magnetic dipole and start integrating in this area. And by taking some ring elements, maybe I expect the answer to be same only. We can check it that way as well. Okay.
First, we need to form a ring, and
First, we need to take a magnetic dipole here. Let us say this is M2. First of all, component of M2 along axis is M2 cos theta. So small magnetic dipole I will take. Due to magnetic dipole, we know the field in different locations by the formula of, if I,
Km.
for
sin
example, if
theta by r.
it is P, then I told you that how to find at an angle theta, right or not?
Yes, sir.
Yes,
Taking
sir.
components.
Same way, we will find out this vector here. What is the vector field here? We will find it out. After finding that, we will take this theta angle will be made not only in this place, it will be made symmetrically everywhere in a ring shape. Then I will take 2 pi r dr here. 2 pi, not r, capital R, let us say 2 pi into capital R into dr. That will be the area of this, multiplied by field passing through that with dot product also. Dot product, because field, what is the angle between the field and the area, that is important. So dot product with that. This is taken as area vector. Its direction will be along I cap. I can say 2 pi r into dr along I cap. This is area vector dot magnetic field. This magnetic field is, yes.
2 pi r dr. Why did you write?
2 pi r dr, it is a ring element here. I will find the
It
field
is
due to,
both a ring node, not discrete.
huh?
It is a ring node, sir. Ring carrying current. You are taking ring elements means you are considering it as a
No,
disk.
you are completely lost. I don't know whether there was a correction loss or what happened to you. You're completely thinking wrongly. I'm saying that I can find by taking current in the smaller without going to the bigger one. Here I have changed the situation completely. For this, I'm not even interested in finding it here now. But if it is a smaller one, then I can find the flux with a bigger one. What is the meaning of flux with a bigger one? Flux means B dot A. So I have to take area elements of this or not?
Yes, sir.
I'm taking that. If this is the current here, and through that also I can find out this. Let us do both. We will do both. First let me take B here. What is B? B is equal to 2k m by r cube and then what we are going to do next? B dot this first method I only am taking first. This method only, in which you do this, I have no magnetic field and multiply that magnetic field with area vector. Then I get flux. Let us call it number one. Let us call it number two. Flux in 2 due to 1 is equal to, this is a magnetic moment of 1. This is
Into pi a square.
Into pi a square cos theta dot product, right? I will write 2k m1 dot a2 divided by r cube, which I can write as 2k I1 into a1 dot a2 upon r cube. What is that finally? Phi 21 is equal to 2k into a1 dot a2 divided by R cube upon I1, and that is a mutual inductance. We are getting the answer already. Mutual inductance is this 2k A1 dot A2 upon R cube. Only for which cases? When one of the that loop is kept at the axis of the bigger loop. They are coaxial. Their axis is same. Or and axis is not same. Sorry, but I mean this its axis will be this. But I can say that the
Centers on
axis
same.
of the axis of the bigger one has the centers of both loops. Axis of the bigger one has the center of both loops. Okay. So what is other method? Other method will be 512. 512 is slightly complicated. This is mutual inductance, right? And if I know the mutual inductance, then I know mutual inductance of M21 and M12 are equal, or 5 to 1. Here, when I found 5 to 1, that 5 to 1 is also equal to 512. So that answer we have already got here. After that, I'm just telling mutual inductance extra. Maybe find next question. Let us say find mutual inductance also. Mutual inductance. So that is this part here, mutual inductance. Now, no need to write M21 or M12 because these are all equal only. So we can just write it as M. Okay. Sometimes we may still have to write M12 because there may be multiple loops. Inductance between 1 and 2, inductance between 1 and 3, then I will have to write M12 and M13. Okay, that way we have to write. Now, what about this one? Due to smaller, I will take K. This element I will take in. This is the element. And angle subtended is theta. What is this side vector here? I will take it as M2 cos theta and M2 sin theta. First, I will find out due to M2 cos theta. Due to M2 cos theta, what will be the flux to this ring? What is that flux due to M2 cos theta? Can you find it out? Due to M2 sin theta, I think it will be zero flux. Why? If I place a ring in this way, then I think field lines which are entering one side, those will be coming from the other side. So net flux will be, contribution will be zero due to M2 sin theta. Therefore, mainly I'm looking for flux due to M2 cos theta. Is it okay?
Sir, once say again, sir. M2 sin theta y becomes 0.
Because M2 sin theta means it is vertical magnetic dipole moment, means the loop will be like this. For that, I can break this single loop into as if it is composed of two separate loops. One loop giving us horizontal magnetic moment, other loop giving us vertical magnetic moment. The one which is giving us vertical magnetic moment, that loop will be horizontal. The one which is giving us horizontal magnetic moment, that loop will be vertical. Is it okay?
Okay, sir.
So that way we can think, right? Then we can get, I think, by solving this only. We don't need this. So what about due to m2 cos theta? Due to m2 cos theta, I know the field will be. What will be field due to m2 cos theta? That will be equal to can you say
Horizontal and vertical both will be nurtured.
Hmm?
Horizontal and vertical both will be nurtured in element in the ring.
in the ring? Horizontal will be there and vertical will also be there. Due to m2 cos theta only you are talking about.
Except if you consider it as a dipole.
If we consider it as a dipole, then you are right. Well, let me draw a separate diagram for that. If I consider this as a dipole, having dipole moment m2 cos theta, then as you said, it will have again.
Vertical and horizontal ring.
What is the formula for that? Again, I have to split into two parts, right? I have to split this again vector into two parts. One part will be
m2 cos theta into cos phi.
m2 cos theta into cos. This one, this angle is this angle. I have to take theta only. It is
Yes, sir.
theta only. It is same angle, no?
Equatorial m2 cos theta sin theta 2k m2 cos sin theta by r.
This will be m2 cos theta into cos theta means cos square theta. And the other one will be m2 cos theta into sin theta. And at this place here, if some area element is here in this place, this area element is again area element of that smaller one. In this small area element, what will be due to m2 cos square theta? Due to m2 cos square theta, here field will be
2 into k
into k into
Along horizontal 2k m2 into cos phi theta.
k into m2
Cos phi theta by r cube, sir.
cos square theta by r cube. That is the field due to this. And direction of that field will be this side only. Same side, right? Axial field will be in the same direction.
Equatorial.
This that is axial. That is b axial. And what is b equatorial? That will be in opposite. Equatorial will be in opposite direction. Okay. This is b equatorial. What is equatorial formula? In that minus sign, minus means direction is already opposite, but in that case, k into m1 into cos theta sin theta by r cube will appear. Is that right?
Yes, sir.
Yes, sir.
So
So it is m2, sir.
it was m2, correct only. It was m2, sorry.
It is
Now area vector is along I cap of this small element. This actually this is again one element was this, but it is element of that element again. So whatever, right? I am taking due to this. So to this in this small element, what is the final answer of flux? That same flux will be actually through the entire also because it is symmetrically located with respect to m2 cos theta. If I have a dipole of m2 cos theta, means I have vertical loop. M2 cos theta means vertical loop. If vertical loop is there, then all these will be carrying equal flux. So let us find flux through this small part first, through this small part, and then we can get same way in the whole. To
Sir,
this small part.
at area element is along horizontal, so we need to take only horizontal magnetic fields.
We need to take only horizontal, correct only. That's what I'm saying. We need to take only horizontal magnetic field because area vector is along that side. So I have to take components of these components again. What is it? Theta. Then this will be theta here. And this one will become, other side it will become. What would it become? I think 90 minus theta.
90 minus theta.
Other side it would become 90 degrees minus theta. Then we will be getting B axial into cos theta and B equatorial into
Sin theta.
sin theta. Sin theta. And what do we get? Then we get it as B axial cos theta minus B equatorial sin theta. Equatorial cos theta minus B equatorial sin theta. That is it. Into area vector. Area vector will be I can directly take the area vector total only, right? 2 pi r into dr, because I know ultimately it will be passing through that only. So horizontal magnetic field into the total area vector 2 pi r dr integral will give us the net flux in 1 this time due to second, and I want to see whether it comes out to be same or not. I want to see it. Let us check now. What is it finally? B axial cos theta. That will be 2k into m2 by r cube into cos cube theta minus
Cos theta into cos 2 theta we
m2
can
by
write.
r cube.
Total nothing.
After that, cos theta sin theta, but again sin theta. So it will become cos theta into sin square theta, right? Into whole into 2 pi r into dr integral. I don't know it is easy to integrate or not. Don't worry. I'm doing for the first time only in this class only. So if we are not getting same, then don't worry. But means obviously we will be getting same. There is no doubt about it. It is not like something which I am only making up. It is a law. It is of fundamental importance, and we can get the result by advanced mathematics. But unfortunately, I cannot use it in your class. So I'm just wondering that whether we can get it by fundamental maths also or not. By advanced, I know there are well-defined ways to get the answer. Why phi 2 1 is equal to phi 1 2. But I'm just worried about one thing. Maybe this will give us approximate answer. If it gives us approximate answer, then that approximate answer may not match with phi 2 1. Okay. But I think likely we may get exact answer only. But let us see. If not getting exact, then don't get worried and don't get into this thinking that this will not be equal. Means this will definitely be equal. There is no doubt about it. Okay. K into m2 can be taken common outside.
Sir,
And yes,
2 pi capital into dr.
2 pi.
Capital into dr means
For
we are
ring
taking
no,
a
sir.
small element in the ring. Or something like that.
This is capital R, right? Small element. Am I using here small? I use normally small r for this. Then should I call it capital R or what? Capital R. Huh? Capital R also is not good. I think let me call it y then. It is y. Then I should write 2 pi into
Why?
y into dy. That is better, and this r is different from that, right? Good to point it out. This r is oblique distance. This r is oblique distance. This is y here. Then what do we get now? K into m2 taken out. That is constant only. 2 pi can also be taken out. That is also constant only. What we are left with? We are left with just cos cube theta minus cos theta into sin square theta upon into y upon r cubed out.
Doubts.
Yes.
When we are taking theta, we are taking the same direction of area element as smaller loop, sir.
When we are taking theta, we are taking.
Here where you mentioned theta now, sir. We also mentioned theta for area element of between axial and area element of smaller loop.
This also I should represent by different variable. It seems.
That's what I'm saying from the first, sir. That's why I said 5.
Yes, you are right. Only again, That another thing I was saying it wrong. But it is okay M2 cos theta here. There is no problem. But the problem is here I took theta. That is problem. This was different angle and this is different, right? You are right only. Phi. Then it will make a lot of changes everywhere. I think. So what changes it will make? Will it make any changes in the magnetic field? No. There it is fine. It seems. No, it will no, it wait. This is M2 cos theta's component. M2 cos. This will be phi here. Here itself it will be phi. It will be phi here. It will become cos theta cos phi, and it will become here cos theta sin phi, right? This is phi. Then the further in this place, it is M2 cos theta cos phi in place of cos square theta. Cos theta cos phi, and this angle is again phi only, and this is 90 minus phi, and this one is again sin phi, and B equatorial into sin theta. Sin phi means it will become sin square phi since into sin phi, and this is into cos phi. Then what changes it will make here? Phi. What changes it would make here? It will become cos theta into sin square phi. Cos theta times sin square phi. And next we have cos theta into what was next? Cos theta cos phi, again cos phi.
Sir, it is cos square phi only.
Which one? First one.
Yes, sir. Cos theta into cos phi into cos phi.
And second one is
Sin square phi.
cos square phi, and second one is sin square phi, I think. Correct only. Then we get it as what do we get now? Two km2 into 2 pi into cos theta is a constant here, right? We can remember this thing is a constant, but phi is a variable, right? Because this angle will remain fixed of M2 with our axis, but phi will be varying depending upon y and r. This phi will be varying. This is x here. Sin phi will be varying as y upon r. I think x is also constant. We can try writing everything in terms of x. Then it will make things easier. For example, I can write r as
X
x
secant phi.
secant phi, and I can write y as x tan phi, and dy as x secant square phi into d phi. Right? Everything in terms of what is area vector? Area vector 2 pi into dy will become 2 pi into x square into tan phi into secant square phi into d phi. Right? 2 pi x square. So what would it be finally? 2 pi is already taken out. Inside km2 is also taken out. We are left with cos theta in upon r cube into cos square phi minus cos theta into sin square phi upon r cube
2 cos theta cos square.
into y dy, right?
First term into 2 will be there. Sir.
Where?
Cos theta cos square.
In this place. Now What is y dy? Y dy is coming out to be
Y equals to x tan phi.
x is y dy only. Y dy is this thing, x squared tan phi secant square phi d phi. Okay, and r cube in the denominator. R cube will be x cube into secant cube phi. Numerator is 2 cos theta into cos square phi minus cos theta into sin square phi. This is it. Limits going from k into m2 into 2 pi. Limit will be phi will vary from 0 to theta. Phi will vary from 0 to theta total. That is our value of flux in 1 due to 2. Now let us see what do we get. M2 into 2 pi x cube and x square. So I can take 1x outside upon x outside. Remaining term we have to solve inside the integral only. Luckily some terms are getting cancelled. Secant cube phi, secant square phi. This
Cos
is
theta
getting
we
cancelled.
can take common, sir.
Cos theta can be taken out.
Yes.
Yes, cos theta is coming here, right? It was in this as also, right? Cos theta can be taken out. Cos theta is also outside only. Then we are left with 2 cos square phi minus sin square phi into tan phi into secant square phi upon secant square phi will also go here away. Then we are left with 2 cos square phi minus
sin
square phi whole into tan phi divided by secant phi d phi. This we are left with. This also sin phi upon cos phi. Cos phi will cancel this. It will be sin phi finally. Sin phi will get multiplied with that. 2 cos square phi minus sin square phi into sin phi d phi. What is sin phi d phi? Sin phi d phi can be written as d cos phi minus d cos phi. Right or not? This tan phi upon secant phi, I'm writing it as sin phi. Tan phi upon secant phi, I'm writing it as sin phi. And I know that sin phi d phi can be written as minus d cos phi. Using these two, I'm getting this. And other term is outside as it is. It is without any changes. Okay. Now tell me, what is this giving us? Not difficult integration, it seems. 0 to theta we have to integrate. And first one is just 2 into cos minus will appear. Let me take care of this minus sign first. Or forget this minus. I want to find magnitude wise, otherwise also flux, right? Direction we already know. Let us not worry about minus much. I am taking magnitude wise, so it will become 2 cos cube phi by 3 minus. I can write sin square phi as 1 minus cos square phi. In fact, let us do first that only. I will write it as 1 minus cos square phi. It will become 3 cos square phi minus 1 into d cos phi with minus sign. So that minus also I will cover up in this only, and I will write it as 1 minus 3. I think that only is okay finally, 0 to theta. And outside term as it is. Then we are getting cos phi minus 3 into cos cube phi by 3 and 0 to theta. So it will be finally theta only 2 pi k and 2 into cos theta by x. What is it finally? 2 pi k into m2 cos theta by x into cos theta minus cos cube theta. Is it that only? Which is different. This is the flux linked in 1 due to 2. What is cos cube theta, by the way? Cos cube theta we can write as
Taking cos theta is common, 1 minus cos square theta. Sir.
Sin square 2 theta.
taking cos theta common and 1 minus. Then, okay, yes, right. Then we can write 2 pi k into m2. So cos square theta into
1 minus cos.
next. What is sin theta? Sin
Theta
theta.
by 2.
Sin square 2 theta.
We can write that, but I want to get the answer in that terms which we had written before. I can write in that way, but what answer I was expecting to be there, I was expecting it to be same answer as before, because mutual inductance is same. A1 dot A2. I want to write answer in that terms, and also R should also be there. How to write in terms of R? First, I'm thinking that in terms of R, if I have to write, then I have to write x secant theta will be R, right? X secant theta will be R. So we get, first of all, sin theta. What is sin theta? B divided by B by R is sin theta. So I am getting already sin square theta is already giving me two terms, B square by R square. And I can take x secant theta. Why? How can I take x secant theta? By bringing one cos theta down. Then that will become secant theta here, right? One cos theta will remain here. And x secant theta I will put as R. Or indirectly I am saying that x divided by cos theta, which is already there, that I am putting it as R. So we are getting that R cube down below. 2 pi k into m2 upon R cube. And what about sin square theta? That is just B square.
B square by R.
One cos theta is still remaining, I think. That is still remaining. But we know that pi into B square was, what is pi into B square? That is A1. So we are getting finally k m2 cos theta into A1 into m2 upon R cube into 2. Is it right or not? Right?
A1 into A2.
Yes, sir, right.
But
M2 two times
A1
1
into, I have done 2 times here. Why? Wait a second.
Into
M2
A2.
will be once only. Now I can write M2 as 2 into K into I into A2. So it becomes I
A1 dot 8.
into A1 A2 cos theta upon R cube, which is 2K into I upon R cube into A1 dot A2. What was it before?
Same as it.
Same as it is. It means we can verify it now that it is same result. We are getting same mutual interest. Okay. So obviously now you see one thing is, one way is this complicated method. It is really complicated or not? Second method. So how should we do therefore now onwards? Whenever they are giving current in this and they want to find out flux in the first one, don't go for that. Just change the current from the smaller one to the bigger one and then find the flux. It is taking just few steps. See, so quickly we are getting answer just in this place only, one step only almost. Therefore, follow that one. Follow this methodology. Is it okay? Okay. Right. Second one is this question. Can you find out the self-inductance of these two wires? Self-inductance of these two wires. Self-inductance per unit length. Self-inductance per unit length of two interparallel current carrying wires. For two things we say mutual inductance. For one thing we call it as self-inductance. Here it is one thing only. Or is it two? This also we can put this here. And what is happening first? I have to take flux due to one wire at a time. And I'll try to make the wire a little bigger for clarity. Oh. What is the radius of this? A. And A is very less as compared to the distance between these wires. Distance between the wires is B. B. B is much greater than A. So if the current is I in this in upward direction, what is the flux due to that? From where to where we are finding the flux? I'm taking one element here. In this element, I'm finding the flux first. And then I'm integrating it. Length is taken as L. This is here dr. Then we get it as L into dr.
Into mu naught I by 2 pi r.
Into mu naught I by 2 pi r. L into dr into mu naught I by 2 pi r. Okay. Next, that into this into what? This is I, this is I. So, same integration as we are doing always from so long. Limits from A to B, center to center distance is B. Then what flux we are neglecting here? We are neglecting the flux within the wire. That is also there. So that may be negligible as compared to this total length because B is very large as compared to it. So this part we are neglecting here. Next time I will take that part also into account. Okay. Mu naught I by 2 pi r into L into dr. What is that answer finally? Mu naught into I upon 2 pi into L into ln of B by A. That is only, it is not net flux. Don't think it is net flux. It is just due to one wire only. Same flux will be due to the other wire in the same direction also. So what will be the net flux? Let us call it flux due to wire 1 and flux due to wire 2 within them. That will also be equal to phi 1. And phi net is equal to 2 into phi 1, which is finally equal to mu naught I into L divided by pi into ln b by a. Is it okay? That is the net flux. What is the flux per unit current? That is the self-inductance. What is the self-inductance coming out to be? Mu naught
Not
into
L by I non
per
B.
unit length, let us say. Self-inductance per unit length. Then
Length
we
will
get it
not be
as,
there. It will not.
then mu naught into ln b
Will
by
by
a
pi
divided by pi. That is the self-inductance per unit length.
length.
So we found it. Why we are calling it as self-inductance? Whenever we are calling self-inductance, then understand. It means it is like one loop. It is like one loop only. It is going somewhere and returning back, and it is forming a one long. I can say it is also self-inductance of one long rectangular loop. For that also we can say. I have to neglect the flux due to this wire and the other wire. This is already small and this is also small. We can probably neglect the flux due to that. So we are left with only the flux due to these remaining two wires, which are long and parallel wires. So that flux will be this only, right? We can get the self-inductance in this way. Now next is, what about this one? Solid cylindrical conductor inside a hollow cylinder. This is different from the last case now, because here I am really taking A to be large enough. So somebody may think that again we can get the flux in the same way, but it is solid. Inside flux also I want you to take into account. But how to take that into account? It is difficult to tell, because I don't know in what way the current gets divided. There is another method to do this easily. Energy method. Do you know what is the energy of a inductor? What is the energy of inductor formula?
Half
Half
Li
Li square.
square.
Half Li square, right? We will use that one here to get answer for this. We will use that one here. Okay. Solid cylindrical conductor inside hollow cylinder. So what was that? So now half Li square formula I have to use. That will be easy to get the answer from that. Half Li square will be equal to total energy stored. Now you may think, if half Li square is there, then also how can we get the answer if L is also not known? Actually, we have another way to get the magnetic energy density. And magnetic energy, that is half B square by mu naught, remember, multiplied
Yes,
by
sir.
D volume integral. This is also another way to get this, right? So we can, but the thing is here, we are assuming its permeability to be equal to mu naught only. Very unreal situation. Practically no material will have that permittivity. Every material will have magnetic permeability as, it is called as magnetic permeability. Every material will have magnetic permeability as something different from mu naught. Okay, so it will not be equal to mu naught. Mu naught is only for vacuum. But if we assume that it is current flowing through some sort of material which has very less permeability, or it is almost equal to vacuum permeability, then we can use this one. Okay, but this is how they do it in different texts I have seen. So we can also get in the same way. Magnetic field we know everywhere, right? If it is a long cylinder, then we know magnetic field within this easily. How can we tell? There's a formula for that. If you remember, mu naught into, or Ampere's law. Use Ampere's law if you are forgetting. We can use Ampere's law. By Ampere's law, magnetic field inside will be obtained easily by taking some axis here, and then this is at a distance small r. So we can write mu naught into current enclosed. Have you written the question here? Question is to determine
Self-inductance.
To determine self-inductance. Inductance of coaxial cable. Coaxial cable. There are two kinds of coaxial cables. Last time also I have taken coaxial cable, but in that time I was taking inner one also as hollow. Here I am taking inner one as solid. Okay. Now this is just a hint that we have to use it. But how to get B? B we will be getting as by Ampere's law. We can get B by Ampere's circuital law. So we know B into 2 pi r. B into 2 pi r for r less than A. This is equal to, what is it equal to? Mu naught into J into pi
is
r square, up to r only. Up to r only, what is the current enclosed? Okay. Then we are getting B equals mu naught into J into r by 2. That is B. What next? So we are getting B, then we are getting B into what? What we have to take now? This P is at a distance r, and it is passing through a. If I take a, no, sorry, again I was doing it wrong. That we should not do, but I was trying to do again. What we should not do is, we should not take the flux due to this B. Here aim is not to take the flux. Reason is, we don't know this flux is linked to what loop we can say this flux is, because the current is distributed through this entire space. It is not like single current carrying loop we can't take here. It is like several current carrying such loops are finally converting into a single loop, so we can't tell what is the flux linked here. Don't do the flux by the flux method. Rather than that, we will do by energy method. This way we can find out the energy. What is the energy stored? Half into B square by mu naught into what will be the energy in the cylindrical region? In the cylindrical region, what will be the energy? What will be the energy in the cylindrical region?
Sure.
Yes.
Can we take B as mu naught J into capital R by 2 for the whole cylinder?
It is a good. Which was that? This one. Can we take what?
B as mu naught J into capital R by 2 for the whole cylinder.
Mu naught B into
B equals to mu naught J into capital R by 2 for the whole
no,
cylinder.
we can't. How can we take for the whole cylinder? That will be just at the surface. It is at a distance r.
Yes.
It is at a distance r. It is at a given distance r. How that will be for the whole? It is varying. It is varying. It is varying linearly. You can see from this also. It is varying linearly with.
Surface.
It will be varying like this here. It will be increasing linearly, and then after that it will be varying in this way outside. This is r equal to, what is the inner radius? This radius is a. R equal to a. This is how B varies. At the surface, it is mu naught into J into capital A by 2. A is the radius. Okay, so this formula is for R less than R, not R, means R less than A. For R less than A only, this is applicable. Which one? This one. Okay.
Yes, sir.
Now you tell. What is energy density? Energy stored inside the solid cylindrical part. B into B square by 2 mu naught into what is the energy in this cylindrical region? This cylindrical region will be there. What will be energy stored in this? Here magnetic field is B. So we can say energy density into volume. What will be the volume in this? Volume will be 2 pi R L into dr. 2 pi R into dr into L. This is it. This is energy inside. What is energy outside? For outside, we can simply take mu naught I by 2 pi R. Okay, B for R greater than A. B for R A to B will be just equal to mu naught I by 2 pi R. What is energy density then? Then also energy density we have to do by integration only, we will be getting again. We have to do the integration in that case also. Okay. Let's call this energy as U1. Similarly, U2 I can get by taking magnetic field. This is, let us say, B1, B1, B1. And what is in this? It is taking B1 and this I'm taking as B2. This is B2. What is U2? U2 will be B2 square by 2 mu naught into 2 pi R L into dr. Limits R varies from A to R equal to B. Here limits R varies from 0 to R equal to A. These are the difference of the limits. Now do these integrations, and from there we will be getting the total energy. After getting the total energy, what we are going to do? That hint is given above. That hint will be useful now. Right or not? Mu naught square into J square upon, I'm trying to put the values of B here. Mu naught square J square upon 2 square. 2 square will be 4 and 2 is also there. This 2 and 2 is already cancelled. Upon 4. Into L will be coming. 1 mu naught will be below. And pi will come in the numerator. Remaining all are R. R here and R square here. So it is R cube dr. Please check the calculations. I am doing it wrong very many times. What is U1 coming out to be then? U1 will be then finally mu naught square into J square into L into pi upon 4. Mu naught is, this is into A raised to power 4.
Mu naught square, sir. No, sir. No.
Not now. Here is over 4 by 4.
Nothing, sir.
I think this only, but check the calculation also. After that U2. U2 will be similarly mu naught square into I square upon 4 pi square. Again, this 2 and 2 is cancelled. 1 pi comes from inside, 1 L comes from inside, 1 mu naught comes from inside. Pi above, L above, and mu naught below. Remaining is all R only. R square from here because B square and 1 R is here. So we will be getting finally
R cube by
Ln B by
1 by R, 1 by R dr and A to B, not R cube. It was in denominator and that is in numerator. So we are getting then finally I square
One will
into
be
1 L upon 4 pi mu naught remains above and ln b by a, that is u2. U2 is there. What was u1? That also we have to check. I have to write u1 again in terms of I. So I can write j as I upon pi a square. Then it would become mu naught upon 4 pi will appear. Yes, pi will appear. And what will appear? I square will appear and L will appear. And a square, a raised power 4, but here it will be j square. So a raised power 4 will be in denominator also. That will be gone away, cancelled. Then 1 4 remains here. This 4 is also there. Then it will become 16 pi, I think.
Yes, sir.
That only? Or have I skipped something?
That one is
That only. Then mu naught I square L upon 16 pi and mu naught I square L upon 4 pi into log. So overall, u1 plus u2 is equal to mu naught taken common, I square taken common upon 16 pi taken common, and L is also there, I think, in both. L is also taken common. Inside we are left with 1 plus 4 ln b by a. Right or not?
So you have forgotten.
yes, sir.
That only. This is the total energy. So, and I know total energy I can write as equal to half L I square. What would be then value of L we can calculate from here? L will be equal to mu naught L upon 8 pi into 1 plus 4 of ln b by a. This is self-inductance of that cable. Also,
Sir?
yes,
Nu1 value 1.
what?
One show that Nu1 values. Okay.
Okay. This is net energy, but net energy is also equal to half Li square. So we are getting this self-inductance, right? Self-inductance per unit length I can determine whenever there is something long. Then usually we are not interested in that self-inductance, but we are usually interested in per unit length only. Mostly we do that only for long cases.
Sir,